All right, so going along with the last example, here's another situation where we want to make sure that we're really careful of when and how we use the intermediate value theorem. So here we have a function 1 over x, f of x equals 1 over x, where we have this interval from -1 to 1, right? And f of -1, in other words, f of a is -1, so it's less than 0. And f of +1, right, which is +1 is our b, that's of course greater than 0. Can we conclude that f of x has a 0 in the interval from -1 to 1, right? And so let's just kind of picture this graph for a second. So we're saying that f of -1 here, right, is equal to -1. Let me give myself a little more room here. So we're saying that the graph has this point here, right? And f of +1 is positive, the output is +1, so that we have a point here. So then it's saying, can we conclude that we have a 0, right? Well, yeah, remember the intermediate value theorem. If I can't pick my pencil up from the paper, then to get from point A to point B, I'd have to cross through 0, correct? Well, not so fast. Remember that one of the qualifications of the intermediate value theorem says, and almost the first thing it says let f be continuous over a closed bounded interval a to b, right? So it has to be, we have to have a continuous function. So let's ask the question, is 1 over x, is that continuous from -1 to 1? Is that continuous on this interval? And the answer is, and this is where it's important to understand where discontinuities happen, right? So 1 over x, that has some limitations, right? If I have a variable in the denominator, then we have the potential of having a 0 in the denominator, right? And so when would this denominator be 0? Well, it would be 0 when x equals 0, right? And so at x equals 0, we have a discontinuity, right? And this would be actually an essential discontinuity because there's nothing on top that would cancel, right? So there would be a vertical asymptote actually at x equals 0. And so it would be an infinite or essential discontinuity at that point, right? And so the intermediate value theorem does not apply to this situation because f of x is not continuous on that interval. Okay, so in order to apply the intermediate value theorem, the function has to be continuous on that entire interval, right? And that's not the case here. So IVT doesn't work. So the answer would be no, and the explanation would be because f of x is not continuous on the interval from -1 to 1. Okay. All right, so let's take a look at this example here. So we're trying to show that this function f of x here has a 0, right? So that means that f of x equals 0, sorry. F of x equals 0 over the interval from 0 to 1, right? So first of all, we need to ensure that this function is continuous from 0 to 1. So is f of x continuous on that interval? And the answer is yeah, this is a polynomial, right? This is continuous everywhere. And so so the answer is yes. Okay, so that's a check. All right, so now we just need to find that from 0 to 1 that we have some points some points in there where we have a negative and a positive, right? And so the easiest thing to do, and usually what happens with these is you just plug in 0 and you plug in 1, and hopefully you'll get a positive and a negative. If not, then you might have to investigate in between 0 and 1 and find some values in between. So let's just find f of 0, So f of 0, if I plugged in 0 for all these, and you don't have to show all this work, if you plug in 0 to a polynomial, you're just going to get the constant, right? Because all these things are going to go to 0, and so all you'll get is 0 plus 1, which is 1, right? So f of 0 equals 1. So that's positive. So I'm hoping that f of 1 is going to be negative. So if I plug in 1 to as my input for all these x's, I would get 1 cubed minus 1 squared minus 3 times 1 plus 1, right? And so 1 cubed is 1, 1 squared is 1, negative 3 times 1 is negative 3 plus 1. And I don't really need to know exactly what this is, but I need to know that it's, or I want to know that it's negative, right? And that's the case here. So this would end up being negative 2, but the main criteria, or the main thing that we want to take away, is that it's negative, okay? So we know that f of 0 is 1, and f of 1 is negative 2, and we know the function is continuous between 0 and 1. So that means to get from 1 to negative 2, we have to cross 0, right? To get from a positive to a negative, or a negative to a positive, we have to cross 0 if that function is continuous. And so by the intermediate value theorem, we can say that there's some value, some input c, that gives you an output 0 on the interval from 0 to 1, okay? So there's some value c, right, between 0 and 1, so where c is greater than 0 and less than 1, there's some value c where that, and it could actually be equal to 0 or 1, but there's some value c that that provides an output of 0, okay? All right, so that's how to use the intermediate value theorem. Is first of all, make sure that function is continuous on that interval, and then try to find values that are on either side of whatever you're trying to find. So if you're trying to find a 0, you can find a positive and a negative in that interval. If you're trying to find 5, then you need something less than 5, something greater than 5, right? If you're trying to find that there's an output of 5 or whatever. So, all right. Hopefully that makes sense. Yeah, a little bit tricky, but yeah, hopefully that'll hopefully that's intuitive to you, even though sometimes the language is a little confusing.